Now we're going to get serious and actually take advantage of what a vendor can truly do. So I'm going to reopen the expression where we created a vendor that contributes just a flat design when contracted. If we take a look at the layered design we're going to upgrade it with, we can see that we've already contracted 5 of the 6 unique suppliers that we're going to be needing. So first I'm going to go ahead and just automate the contracting of the new procedure supplier, that new one that wasn't contracted in our flat design. Just going to select that. Lo and behold, it's Dow again. If you're unsure about that, that's just the redundant procedure that we need in the case where the design time maximum of the bit index is less than or equal to the length of the bit array. So it's a procedure that's actually never going to be called. Now if we jump back here, these 4 suppliers in blue are common to both designs. We could contract each of them twice and basically lay down 2 separate algorithms for each of the cases, one where the maximum bit index value is greater than the length of the bit array, and the other case where the maximum bit index is less than or equal to the length of the bit array. But in future, when the vendor we're expressing will be built by the marketplace of vendors, it's going to be a pretty expensive endeavor, especially if your design becomes very layered. It's better to automate for the unique suppliers and conditionally organize where they get their information from. Because we know no matter what, we want to contract these 3 suppliers here, which are also here. It's just that some of their DOFs are going to be organized into different committees, depending upon design time information. So if we jump back to the vendor principal, there are a couple of DOFs here that I can quickly organize. That construction site, it requests access to the main flow so it can initialize the procedure. So I'm going to add that in here and just organize it first. It provides us with a handle to the reference, which no one's going to use because this procedure won't be called, so I'll just minimize that. And then gives us access to the construction site in which any work that's going to be in the procedure will be organized. I'm going to leave that hanging for a moment. Now if we jump over to processing, we can start making this guy smarter. So we're going to be making use of the information a vendor has access to at design time. This includes the maximum possible value of the bit index, which is here, we didn't use it before, and the length of the bit array, which one of our suppliers requested as design time information. So we want to compare this value with this one here. So I'm going to add a new process from the logic called compare. We want to compare the maximum bit index value with the length of the bit array. So input 1, we've got to be careful about the ordering here because it will affect what these mean. Input 1 is the bit index, input 2 is the bit array length. And the further documentation on this processing is available in the Valley standards. So input 1, I'm going to plug into this source noun value. Input 2, I'm going to plug into this length. And that comparison is done. Now the 5 nouns for the events that could trigger off that comparison have been created for us. So we've got a trigger if those values are equal, which we don't care about by itself. We've got a trigger if the bit index is greater than the bit array length, which we do care about. We don't care about this lesser one, so I'll minimize that. We don't care about the greater or equal. We do care about if the bit index is less than or equal to the bit array. So I'm leaving these 2 source noun events open because we're going to be plugging some stuff into there. Too easy, right? Now looking at the design, we can see that we want to chain the division, the addition, the set bit, and the bit added construction site term in 2 different spots, depending upon whether at design time we establish the bit index maximum is greater than the length of the bit array, or if it's less than or equal to the length of the bit array. So this means we actually need 2 mutually exclusive copies of each of these construction site DOFs in our expression so that we can conditionally organize which committees they will be in. And the vendor principal makes this pretty easy for us. But first we've got to go back to our communications panel and just remove the relevant construction site DOFs from the committees, because we're going to be doing some processing to them. So in the false case, when the design was flat, we were always doing a runtime comparison. We weren't making use of the information available to us at design time. So now I'm going to take out, there's the division, the addition, the set bit, and the bit added construction site term. So if I go back to processing, we're going to add a new process called, funnily enough, split rep. I'm going to label it the name of the rep I want two mutually exclusive copies of, in this case the division construction site. Then I'm going to select the rep I'm wanting to split here, and here we can label the copies, select how many copies, how many mutually exclusive copies we want, and then just label them accordingly. I usually label them after the thing that they're being triggered off. So we want if the max bit index is greater than bit array length, and our other case is if the max is less than or equal to the bit array length. You can see we now have two copies of the rep here and corresponding sync triggers. It's our responsibility to organize these syncs with the appropriate source events, which must be mutually exclusive. So I'll put the first one in this greater source event, greater, and the second one in the lesser or equal. Now I'm going to split the addition construction site. This one. Going to organize these triggers in the appropriate spots. And I'm going to split our last two reps. The set again, organize those mutually exclusive triggers. Relabel that. And we also want to split that construction site term. Last one. Excellent. Now that we've got all these reps triggering in the correct events, I'm going to go back and organize each set in their correct committees. So if we check back at our design, we want one set to be organized in the false construction site from that comparison, and the other set to be organized in the main construction site. So going back to communications, there's the false construction site, and that's where the bit index is out of bounds at design time. So we first want to divide, then we want to carry out the addition to determine the location, then we want to set the bit, and then we want to trigger bit added. So these are all the mutually exclusive reps that will trigger when the bit index maximum is greater than the bit array length. The other ones we want to trigger in the main construction site, which is up here. I'm going to organize, there's the division, there's the addition, there's the set, and there's the bit added. Now this compare vendor here, we've got to make sure that's also conditionally contracted. We only want it to be contracted as per our design in the case where that design time maximum is greater than the length of the bit array. So I'm going to go back to processing. Now, if you remember from our earlier expression, we triggered that comparison when the bit index integer was of type x64. So now I'm going to remove that from that committee. I'm going to add a new process. To bit index. So when the bit index is of type int64 and our max bit array, max bit index is greater than bit array length. We've got an extra condition that we need. We've got an extra condition that we want to be true in order to trigger the comparison. So I'm going to AND those two events. We want to. So the first one that needs to be true is that the bit index is int64, and the second one is if the maximum bit index is greater than the bit array length, input 2. So under this source event, I will trigger the comparison. If we jump back here, our procedure should only be triggered in this case here. So I'm going to go organize its trigger underneath that less than or equal to source event. Minimize those. So we've correctly triggered when this comparison should be contracted. If we jump back to our designs, the last thing we've got to take care of is this index out of bounds construction site term. So at present, that's organized in the true case, the runtime comparison, where the runtime comparison tells us the index is out of bounds. That's organized there, and if I create a new committee now for the body of that redundant procedure, that's where we also want this term to go. So we could do a split rep and organize it conditionally in that committee or this one, but because these two chair committees are mutually exclusive, we can actually use a different kind of processing, still in the same family as split rep, called merge chair. This can only be done on mutually exclusive chairs though, which is why we couldn't do it earlier. So merge chairs. So this is essentially our index out of bounds construction site. So the type is construction site, so I'll select that. Now it requires, or the processing requires chairs to select here, and we can't select any at present because they are already organized over here, so I'm just going to go unorganize them or remove those committees. So I'll take that one out, take that one out. We jump back over here. We can now select those two as the chairs we want to merge. Done, and there's the copy of the merged chair. So if I come back here, create a new committee for that, and organize the index out of bounds term there. Done. So I'm just going to do a save as of this, and I'll call it layered design round 1. And now I'm going to build. Yes,
building.
Let's go back to our portfolio. And there it is. She's already built. Now we can go straight away and test it. So I'm going to open up our old test expression and we've got a quick note of our maximums here. So we've got a maximum bit index of 100 and a bit array length of 70. So we should expect the case 1 automation to trigger in our vendor if we were to rebuild this test using the new version of our vendor. So I'm just going to do a save as of this, and I'll call it layered design And now I'm going to build.
Building. Construction complete.
And there it is. Now before I actually run this up and test it, I'm actually going to build the ELF that will test our automation for case 2, and then I'll just run them up at the same time. Now let's go back to our test expression that we just used to build that test and verify that the case 1 automation works. And I'm going to make sure that the maximum value of our bit index is equal to or less than the bit array length. So let's just say it's 60. I'm going to go change that integer design time maximum from 100 to 60. And in this case here, we know that the index out of bounds case will never trigger. In fact, we can't even set the number to be 70 whilst it has a minimum and maximum value of 60, because that set index guy is an integer expert and he follows the rules of saturation arithmetic. So he'll make sure that the number does not exceed the maximum. So I'm going to actually go out and take out the index out of bounds check. So I'll delete add to bit array. Just delete the second one of everything. And now we just have a few empty rep slots in our committees. We do want to set that index. We want to take out the set index out of bounds. The inbound is 60, still fine, but we do want that to be changed prior to adding to the bit array, or it will add at index 0. So I'll make that third. Refresh. So we've got the set, create the bit array, create the number, set that number, add to the bit array, write the bit array, exit. In the success case, we're going to write bit added. In the failure case, we'll write index out of bounds, which we secretly know will never trigger. A new number for the integer. And we don't need these committees. Just going to go ahead and save that as case 2. And build. Making sure I select our layered design vendor.
Building.
Construction complete.
Construction complete.
So there it is. Let's download it and run it up. And we'll download the case 1 and run that up. And verify that our new layers of automation all work properly. You can see now something's happened because our footprint has already dropped to 220. So if we run up the case 1, we expect to see index out of bounds and the empty bit array, then bit added, and then the bit is added at index 60 within the 70-bit length array. Now I'm going to run them up. The first one looks good. And now let's run up case 2. We expect to just see bit added and the bit successfully added at index 60. Looks good. So now we've verified that our new layers of automation work and our vendor is still delivering the correct design contribution. It's just doing so in some ways in a far more efficient manner. So we could go back now to our portfolio and select our new vendor as the primary and publish that to the valley.